Welcome back, everyone. Hope everybody got a little bit of a break there. Once again, I want to remind you to click that join the discussion link for whatever breakout sessions you're checking out. Will take you to Slack, and that's where all the interesting conversations are happening. That hallway track, if you will, that we don't have this year, but that's the closest we could do this year. Up next, we've got Alexey Nesterov with his talk, Spring, Your Next Java Micro Framework.
All right. Hi, everyone. Yeah, thanks for joining. My name is Alexey Nesterov. I'm a software engineer here at VMware, and I'm working in Spring Cloud Services team. But today I'm not going to talk about Spring Cloud Services. I'm going to talk about Spring from the side you probably didn't expect me to talk about, from a micro frameworky side of things. So I'm going to pause for a second on these slides so you can have a chance to read about the safe harbor statement. And I'm going to explain actually where this talk is coming from. So before I joined Spring Cloud Services team, I used to work as a consultant in Pivotal Labs, and I had a chance to talk with many people, work on multiple projects. And sometimes I had this impression that, I got this impression that people, users of Spring Boot and Spring, they were looking to migrate to when they were migrating to microservices from the monolith application or from the traditional application, they were looking to migrate off Spring Boot as well, to migrate to different Java micro frameworks. And I thought, what it is about micro frameworks people are looking for that Spring cannot provide, and maybe Spring can actually provide all of these features. So micro framework means different things to different people, actually. So in my example, so what I've checked first is Wikipedia, which is the most relevant source of truth for us. And the Wikipedia says that micro framework is just something that receives an HTTP request, routes it to the business function, and then gives you a HTTP response. So pretty much from this perspective, everything is a micro framework, everything that has HTTP server embedded. But seriously speaking, actually, I had a chance to talk with different people. I followed the different conversations on Reddit, on different forums and everything. And I tried to aggregate all of these different concerns people have about what they're looking for when migrating off Spring Boot to micro frameworks into these four main topics, which are runtime efficiency, ease of local development, code simplicity, and container friendliness. And I thought, what Spring Boot can provide for all of these topics, basically? Can it just give you anything you need from a micro framework? Maybe there is no need to migrate anywhere. Maybe you can just use Spring Boot in a way which is more suitable for micro framework, for microservices style. And it turns out it's totally possible. So let's have a look at these topics in a little bit more details. So, well, first of all, I want to say that some people migrating from Spring Boot, let's say, to other Java frameworks, looking for runtime efficiency, forgetting that actually Spring Boot itself is very, very optimized and highly efficient framework. So with starting from Spring Boot 2.3, it can actually provide you a sub-second startup times. And the memory footprint of the Spring itself is reasonable, but people like forgetting that actually there's a price to pay when you run on the top of JVM. So JVM is great; it's really a state-of-the-art runtime environment, but it has certain constraints. It has certain requirements for memory and CPU. So if you're basically migrating from one JVM framework to another one, you're going to pay this price anyway. The solution is probably coming in this year or hopefully next year is AOT compilation. So that's a big topic in Java community now. And I'm happy to say that Spring Boot, and you've probably seen it already in multiple talks from Sebastian, from Andy, that Spring Boot perfectly compatible with GraalVM native compilation, and it's already available for you. So you can experiment and try that. So from the runtime efficiency standpoint, it's basically already in a good position. The baseline is good, and you can get even more with GraalVM. In terms of local development, what people are looking for quite often is they said this, I want to say my file and then see changes reflected immediately. And I'm actually surprised how many people never heard of Spring Boot DevTools, because this is exactly what it is about. So you don't have to restart your application or redeploy your application every time you make a change in Spring Boot. You can pretty much just, save the changes, compile the project, get your changes displayed in your browser. Another concern I heard is code simplicity. In Spring Boot, some people say that there's a lot of magic. Well, first of all, I don't believe in magic. There's no magic. There are abstractions, and these abstractions there for a reason. Again, we're going to talk about it in a sec. And the last one is people think for whatever reason that Spring Boot is somehow not compatible or not designed for containers and K8s and other containerized workloads, which is simply not true. All right, let's have a look at this in more detail. So runtime efficiency, as I said, Spring Boot's 2.3 can start in about 1 second, just an application itself with any business logic on startup. But JVM takes a little bit of time to load the classes, compile the classes, initialize itself, warm up, and it's quite a significant time. Well, it's still about 1 second, but it's significant time within this 1 second. And when you actually pick in another framework, let's say, don't just look at one of the metrics. So one of the most popular metrics that micro frameworks show is XMX limitation with heap size, which is completely irrelevant. Like just measure it. Like it's pretty much in many cases. It doesn't even make sense to set it for most of the applications because, again, JVM has its own requirements for memory. And even if you can start your application with 16 megabytes of heap, like how much JVM will consume, you need to keep this in mind. And how will it affect latency and everything? That's another question. So, but also, if you're not happy with Spring Boot, like as is, basically with the baseline it provides, there are some quick wins you can do. So the quick wins can be, you can enable lazy binit init. So with lazy binit initialization, you can basically defer beans creation from the startup to the first request. You can do the same for repositories, for your JPA repositories, let's say. If you're looking to optimize your application for startup time, you can try to use exploded jars. So basically, instead of running your application with java-jar, you can try to run it with, extract the jar file and then run it. If you are thinking about rewriting your application into a set of microservices, you can consider using reactive stack, which is a little bit more optimized for startup and memory pressure. And as an option, if you're interested in actually like some particular metrics in the performance optimizations, you can even explore different JVMs. Maybe like have a look at the Graal VM. Even without native images, it can give you a lot. So in terms of runtime efficiency, Spring Boot is quite efficient from the beginning, but again, you can get some benefits by using these simple tricks. So there is a great research from Dave Sire about how fast is Spring. You can also check that out, and there are a lot of ideas how to optimize your app. So another one is code simplicity and this magic in Spring Boot, which I don't believe in. So it's an interesting topic. So this icon here, this person is Rich Hickey, is a creator of Clojure programming language, and he basically has this great talk about simple versus easy. So Spring Boot is all about ease of development. So it's about how to make your code easy to read, to write, but it's not always simple. But what people don't sometimes underestimate is simple sometimes means actually means writing more code. Actually, it means thinking about the things you wouldn't normally think in Spring Boot application, like wiring your components, life cycle of your components, just starting and stopping the web server, like a lot of things you need to think about in a simple approach. Let's say the code I have in here is fairly easy to read and to write, but it's not very simple because we don't really know what's going on in there. So even book repository is an interface, right? It's going to be generated by Spring Data for you. So it's super easy to write, but it's not very simple. So you don't really have access to the internals of that. The same with the injection. Like say you have this auto-wired field. When it be injected, well, you don't know technically because you're not injecting that. You manually, Spring will do it for you. So what's the lifetime of this one? Is it a singleton? Is it or maybe it's just a multiple instances of this book repository? We don't know. Right, so this is a simple code. This is easy to write and to read, but it's not simple. And opposite to simple is basically complex, and opposite to easy is hard. So you need to keep this in mind when you're looking to simplify your code, that you probably will start writing and thinking about things you never thought before when using Spring Boot. But there are, again, a couple of simple tricks you can do to make your code simpler versus easy. So you can basically prefer functional beans registration to component scanning. You can use functional routing as an alternative to route mapping. I'm going to show it in a sec. And I think one of the common concerns is people are concerned about auto-generated queries by Spring Data. And again, the question is, maybe you just don't need Spring Data. Maybe you can just either annotate it with query and then craft your query manually, or can just use another data access technique like R2DBC or something. And it kind of all sums up into one argument I heard a couple of times, is my application is so small that I don't need any configuration or any Spring dependency management. I can just write my whole application in the main method. Well, good news, you can totally do that with Spring Boot. There's nothing that stops you from doing that. And I'm going to demonstrate it in a sec. So let's maybe start with a little demo. So I have this repo created for this demo. And in here, as a starting point, as a baseline, I have this Spring Boot application, which is a fairly traditional application. I have, let's say, my application class. I have my entity. I have my controller created with just normal mappings and everything. I have my Spring Data repository and, well, again, nothing unusual, nothing you've never seen in a Spring Boot application before. So what I'm going to do first is, because I don't have too much time, I just want to basically, I'm going to skip the runtime efficiency. I'm not going to try to start and measure the application. You can, again, find a lot of research online. Instead, I'm just going to try and introduce a first step in kind of a simplification of code process, which is a functional bean registration. Yeah, let's jump back to the next one. So the functional bean registration looks something like that. So as you can see, I don't have the Spring Boot application annotation anymore. Instead, I have Spring Boot configuration and enable auto configuration. So I'm not using component scanning anymore for my application. What I'm doing instead is I'm actually using an initializer feature of Spring Boot application builder. And in this initializer, I have access to an application context. So with that, with access to application context, I can actually register and create beans in a Spring dependency injection container using by just passing functions into my register bean method. So I can basically just provide a function, Lambda function. How do I want to create my instance? So let's take an example. Have a look at this example of Spring Boot controller. So what I'm saying in here, in these two lines, gonna scroll it a little bit. So what I'm saying in here is I want to register a bean of type book controller. And when the new instance of this bean is requested, I want to call this function to create it. And as you can see in here, I'm just actually calling a constructor of that. So there is absolutely no reflection. There's no magic. There is nothing. I'm just manually writing, calling the constructor and passing the dependencies. So, and the dependencies is an interesting case in here. So I can actually mix and match, so I can get some of the dependencies from the application context, but I can also just pass these dependencies because I'm just using a constructor from everywhere. I can just pass it anything. I can create an object outside of Spring Boot container, of Spring container, and I can just pass it there. And this will be registered as a proper bean. You can auto-wire it if you want to, or you can just, basically do all the normal things you would do with Spring Boot, with the Spring bean. And because it's a controller, it will automatically register my routes in my application, my endpoints, so you can basically start it and run it and get access to that. So what I'm going to do now is I'm going to start the application just to show you how it looks like. So yeah, I'm going to use Spring Boot plugin for that. So when the application is running, so I have it in here, right? It's a fairly simple application. It gets access to the database, to Postgres database, gets a couple of records from there, and it displays it as a JSON result. And I can also use my business logic to actually translate titles of this book into any language of my choice, let's say to French. So this is my application running, and this is a mix of traditional application, Spring Boot application, but without any configuration class and with functional bean registration. So my controller is created using functional bean registration. So the next step is introduce, in addition to functional bean registration, is actually introduce functional routing. So let's move on to the next commit and have another look at this initializer. So as you can see, this is the same initializer basically, but now instead of actually creating a bean of type book controller, I'm creating another bean of type router function. And this router function is a special type of a bin in Spring. So it will basically, I can use a special DSL to construct my routing table using basically this kind of language defined in here. Again, so there is no scanning for REST controllers. There is no any reflection going on. I'm just defining my routing table as a set of basically combination of a method and a path, and then I pass it a function, and a function takes a request, returns a response. That's it. As simple as that. And because we're not using annotations in here, so we have to be very, very explicit. Like if I want to get access to one of the parameters of the request, I cannot just use an annotation request parameter something. I need to be very specific. I want to say I want to get value of this parameter, and if it's not defined, I need to decide what I want to do. Do I want to throw an exception? Do you want to return 404? That's basically up to you. And it's all very, as I said, all very explicit, and it's just a Lambda function that takes a request and returns a response. And you can define as many routes as you want. You can nest them if you want. You can define different methods, so obviously different paths and everything. And you can be, and since it's all programmatic, you can be as flexible as you want to be with that. So you can conditionally register routes. You can basically do anything you would do with normal, just passing Lambda functions around. And with that, if I just restart my application, it's pretty much the same functionality, so nothing interesting to see there. Let's just have a look. So as you can see, one thing I want to mention is it started in 1.4 seconds, and that includes database initialization on a startup. So on a startup, I'm actually running these two scripts, and it's part of my startup, and it's still 1.4 seconds. All right, so the application is up and running. So now I don't have any configuration classes. I don't have any beans defined. Well, I do have a couple of them, but I actually register them using functions, using functional definition. And I don't have any REST controller annotations. I'm defining my routing table explicitly in one place in here, which is just a set of functions. Cool. So this is all about code simplicity. Well, not everything really. So the one last thing I want to show is I'm still using Spring Data for data access. And in my next commit, instead of using Spring Data for data access, I'm actually using R2DBC client to connect directly to the database and then run a SQL query and then map the results. So as you can see from auto-generated client, I'm moving to doing everything manually. So from an easy solution, I'm moving to a simple solution. So I have to write more code, but it's much more, I have much more control over it as well. So I'm writing SQL myself, and I'm actually creating a new data object by myself, and I'm mapping all the fields in there manually. So with that, so that's what we can get in the end with all of these techniques. We have a whole application described in the main method. As you can see, there is no configuration classes, no beans. Well, there are beans, but no bean annotations, no REST controller annotations, and your whole application is defined in here. Cool. So in terms of code simplicity, that's all I wanted to say. And the next one is, I only have 5 minutes left, so I'm going to be very quick on that. So the next one is Spring Boot DevTools, which is an amazing tool actually for local development. I'm surprised how many people never heard of that. So what I'm going to do, I'm going to put it side by side actually. So this is my application running. All right, and just give it a second to start. Right, so this is my application running, and imagine I want to do this interactive development cycle. So I have my application on the right, and what I can do, I can click this live reload extension. So this is actually a live reload plugin connected to my Spring application now, right? And if I just go and change anything in my business code, call it that way, say, sorry, no translation, right? And if I just compile it in my IDE, so what happens, Spring Boot DevTools, they monitor for changes of the class path. And I'm not sure if you noticed that or not, but because my class path has changed, they automatically restarted the Spring application and then pushed an event into live reload, and the live reload automatically refreshed my page. So I got my changes reflected in instantly in my browser. And what I'm saying instantly, because what I wanted to show you, so this is the restart of Spring Boot application, and look how much time it takes. To restart Spring Boot application with JVM running, it only takes 0.196 seconds. So it's about 2/10 of the second to start a Spring application. And this is how lightweight is this, basically. So as I said, with DevTools, you can easily enable this live reload, compile and refresh lifecycle, which you expect from the micro framework. So another one is, I'm not going to go again too much into details because I think there was a talk from Ben Hell about generating images for Docker images from Spring Boot applications. And what I want to say is it's not just supported. It's actually Docker images is a first-class citizen starting from Spring Boot 2.3. So it is supported to production level, basically. So it's not just you can generate your Docker file or something. In fact, you don't even need a Docker file. So using cloud native build packs, and if you want to learn more, go and check out talk from Ben Hell. You can generate a Spring Boot image for your application super easily. So basically, you just run a command. Another Maven plugin command, right? So this is called build image, and that's what it will do. It will actually use the cloud native build packs because I don't have too much time. I'm not going to talk about it, but cloud build pack is an opinionated way to build a production ready image for Spring Boot application. And believe me, when I say production ready, it is actually production ready, and there is so many things you need to consider if you want to make it ready for the prime time. And it's all considered. It's already in the build packs. And it also, in addition to that, so the test file, that's good. That's why I like tests. So if I run it, so basically, if I run the build image, it will generate the Docker image. And this Docker image will also be ready for Kubernetes. Because Spring Boot with Actuator will automatically provide you liveness probes, readiness probes, and even enable graceful shutdown. So your application, your Spring Boot application, containerized with cloud native build packs, will be totally happy to run in any Kubernetes deployments you have. And again, that's part of Spring Boot. Nothing you need to learn. You don't need to learn Docker file syntax or anything. You just run this command and you get it. And just quickly mention on that. So as another feature, what you can do in addition to generation just Docker images, you can generate native Docker images. So by just enabling this feature in your application, in your plugin, by setting this BP boot native image to 1, true, you can actually generate a Docker image containing not the jar file, but the static binary of your application. So let's say if I try to run it now with Docker Compose, my native image, I pre-generated it. It takes a little bit of time. So the startup time of my Spring Boot application in a container using the native image is 0.61 seconds. It's funny because sometimes it actually starts faster than Postgres, and sometimes it's a problem. So that's what you can get actually in Spring Boot out of the box. And this is what Spring Boot gives you. If you're looking for the Spring Micro Framework using this criteria, is the framework should be efficient, it should support interactive development, it should be flexible in its simple versus easy balance, and you should be able to write explicit code for your application. And you want a framework to provide features to build Docker images and be case friendly. Spring Boot can do everything for you. So basically, maybe Spring Boot can as well be your next Java Micro Framework. And with that, I'm going to wrap up and check out all these different sessions regarding the Spring Boot, actually, and generating images and native images. There's plenty of talks on Spring One. And yeah, thanks for joining. That's all I have.
Cool. Thanks, Alexey. Be sure to click the join the conversation link and check out the conversation as it continues on Slack, as well as the Q&A session that we've got in between. Go ahead and take a few-minute break, and then if you want, you can, during that break, you can check out Gary Ferrara on the social track. He's doing some magic tricks. That should be interesting. But be sure to come back because we'll have a great talk next on Spring and graph databases.